just going to make a separate video here and get you folks started on your projects. Nothing's due until 9/7, but it's recommended that you start doing things earlier. That's what these asterisk due dates are. I recommend doing it by then, but we're not taking points off until after the ad period's over, because people may still be joining. But you should get your first couple projects out of the way. The first thing you have to do is make a virtual machine to use for all these projects, and that's PMA 41. And let me explain it, because this might be confusing, because a lot of students are going to choose to use different techniques. So you need to get a Windows VM, and there are 4 ways to do it. The best way is to use this one, PMA 41. This is a machine I made that has all the tools you need already installed. The problem is it's kind of big. If you go here, you download this thing, and it is 17 gigabytes. So if you have a really slow internet connection or a machine with a really small disk, you might not be able to download or run this thing. If you can, it is the best thing to use, and you can run it in VMware or VirtualBox or even other things, I suppose, and then you have a machine to work on. If you can't or you don't want to download and run this locally in a local virtualization hypervisor, then yeah, you already have it. Yes, if you were at the workshop at DEF CON, you've already got it. Yeah, it's the same thing we used at DEF CON. But if you don't want to do that, you can make another Windows machine various other ways. You could make a local Windows 2016 server, which is not the best. The best thing would be to use Azure, because you'll get a Windows 10 machine. And you can get like $100 worth of free credit from Azure. You won't have the tools installed, but you'll have Windows 10, and all the projects have links to install the tools as you need them. All the tools here are freely available. It's just that some of them take a little time to install. So if you do not have the ability to run local virtual machines, because you're using an iPad or something, then use Azure. That's my best recommendation. Then you'll get a Windows 10 machine in the cloud you can use. You could also use Google Cloud, but Google Cloud will not let you use Windows 10. You'll have to use 2016 Server, which is pretty good, but it's not quite the same as Windows 10, and some of the projects won't run quite the same way. But anyway, this is your first job. You have to get some kind of Windows VM to use, because you want to do everything here in a virtual machine, like I'm saying, because some of these projects will sort of mess up your system. And then you can start doing things. And I'll just take a look at this first one, Basic Static Techniques, which pretty much follows the chapter in the book and the lecture. So you'll need malware samples, which are already in the machine that I made, but you can download them here. By the way, whatever machine you do this in has to have its antivirus turned off. You have to disable Windows Defender, or it will freak out and clean up this malware. About half of this malware will shut off your antivirus, and you can't use it. So that's another reason why you shouldn't be trying to use a machine that you use for normal purposes to do these projects, because it's not going to have any antivirus on it. Does City still offer Windows for free? No. But you can get a trial version of Windows 2016 for free. It's 90 or 180 days, and that's what that project leads you to. But you don't get, we don't have those Windows licenses anymore that we used to have. So let me bring up my copy of this virtual machine and show you how some of this stuff works. That should be about right. Okay. I should have a password. Okay. All right. So this is my Windows machine with tools. All right. I must have taken the malware samples off normally the malware samples are right there on the desktop, but I've been using this for a lot of purposes, and I probably moved them around. Downloads. Put them somewhere foolish like pictures. Well, got all the tools. All right, I'm going to have to download the malware. That's not too hard to do. Well, let me do that. I might have removed it or messed it around. I'll put them back on. If you don't have the malware, then you just download it from the website for your textbook author. Let's see. I'm somehow not where I need to be. Yes, I was hoping to get to the top of this window. Right. Right, maybe I need to make my window taller. There we are. Okay. So there we go. The Practical Malware Analysis Labs. All right, I'll just download the exe. Download. And yeah, I've already hit this before. Firefox will not let you download it. It detects that it's malware. So that's annoying. So use Internet Explorer, which is dumb enough to download it. All right, so it's this thing, and download. Good, and save it. Okay, view downloads. A security scan. I hope it's not a good security scan or it will get mad at me. Yes. The publisher couldn't be verified. Yeah, that's all right. Open folder. Yeah, that's right. All right, let's see if I can figure out where the heck it hit it. Come on, come on. File Explorer. Okay. There it is. Okay. It was already there anyway. All right, so here's this thing. It's an executable file. It's a self-extractor. This one here is the one I downloaded through Firefox, and it has size 0 because Firefox nuked it. And all right, if people can't find the project, so let me show you that. You go to samsclass.info. This is good. And then you go to this class here, 126. And let me put this in the chat in both systems. This is real important. This is where you find all the information for the homework. Good. Thank you for asking that question. Very important that people have this. So you go here, and then if you click Projects, they'll all appear there. So click Projects, and it's right at the top. Good. I don't think the link for projects is on the site. Yeah, there it is. Good, good. Thank you. Good. Good. This is real important. The projects are not at the bottom of the page anymore. They're at the top. I put them on a separate page because I've changed them and I've been using them at DEF CON and Black Hat and everything. Good. Anyway, so now I'm going to unzip my malware. I run this thing that did not get nuked and run this. And that should unzip the malware. There it goes, doing something. Yes. It ought to ask me. Ah, here it is. Okay, it's just running very slowly. Woo! Yeah, this machine is not very healthy. I will accept whatever anyway. Ah, there. Now I tell where to put it. Put it in downloads. Let's put it on the desktop. All right. Extract. There we go. All right. Now I finally have my folder full of malware. That's all I wanted. All right. So let's use PeView. Everything should start right from the search menu here. It's all installed. Here's PeView. And let me resize my desktop again. All right. So here's PeView, and I'm going to look at lab0101.exe. So it is on my desktop in the labs folder, binary, chapter 1, lab0101.exe. Okay. So here's what it looks like. And by the way, I think I can make this bigger for people to see. Font. Yep. Let's go to Lucida, bold, 18. Yeah, that's better. All right. So here's what you have. The first thing you see is if you click the top entry, you'll just see the whole file in raw hexadecimal view. So you have hexadecimal values here and readable values there. Every Microsoft executable starts with MZ, and it starts with this program cannot be run in DOS mode appears here. And then there's the portable executable header starting with PE here. And then down here you have the names of the sections, text, RData, and data. And if you go down lower, you see more and more parts of the file. And you can scan it all this way, but the whole point of this program is it helps you understand what it is. So here's the DOS header, which is the MZ followed by other things. And it ends with the offset to the new EXE header, which is E8. And that's where the actual NT header is, E8, with PE. And here's the signature, which is just PE. And then there's a header here with the time date stamp we talked about before, telling you when this program was compiled. And in the image optional header, it has the address of the entry point, which we'll have to play with later. And the image base. This is where it's going to load in memory. Almost every program, every executable thinks it's running at this location, 400,000. It's a virtual address, so it may be running somewhere else, but it thinks it's loading at 400,000. So you'll see that quite a lot as we go ahead. And here are the image section headers. This one is the header for the text section, and it's got the size of the raw data and the virtual size, and as you can see, they're pretty much the same. The data on the disk is 1,000, the virtual size and the RAM is 970, they're pretty much the same. And here's the next section, which is the RData section, virtual size of 2B2 and raw size of 1,000. So that's a little bit different, but it's just suggestive of packing. Anyway, so there's the text section itself, which, as I say, does not contain any readable text. This is raw binary machine language instructions, which we will assemble using tools like IDA Pro to disassemble, but you can't read them easily. And here's the RData section, and you see down here some API calls. This is for imports and exports. Here's the import address table, which lists all the API calls and then the library. So it's going to use these things like find first file and find next file in kernel. And then it's going to use this stuff in msvcrt.dil, and that's it. 2 libraries and looks like a couple of dozen function calls. There's the import directory table showing more information about those libraries and names of all the functions again, and so on. So this is the import and export information, although for an EXE it's just imports. And here's a data section with more information about loading some files. In fact, one of these is actually a, like this is pretty suspicious, warning this will destroy your machine. And this one right there, kern E132, and I think that's actually a kern E1 instead of a kernel, but it's a little hard to tell. But I think that it's actually, yes, kern E132. Yep, 31, 33, 32. In ASCII, 31 is the numeral 1, 32 is the numeral 2. And so this is a fake thing that looks like kernel32.dil, but it's kern E132, which is common. Can determine if they're dynamic, linked, or runtime by looking at the import address table. I don't know. I've never seen anything except dynamic linking. It's a good question, and I don't know the answer. I've never tried to find that out. Probably you could make a file in Visual Studio and choose other modes and see what happened. It's a good question. Anyway, so that's what portable executable files look like. And by the way, I should talk about how you turn in your homework. So once you get something working, like this machine, you'll find a flag. And it's actually that 68 raw data, 6B raw data that is fake. Where's the 6B raw data? No, this one is fake. This 31 is a 1. The 6B, no, I think 6B is actually L. This one here? No, I think this 6C is actually an L. Because Yep, CDE, because LMN. Yeah, it matches. Yeah, this is actually an L. Yeah, 6865, that is NEL. 60656T is NEL. This is the real name. Yeah, 7th row, 1, 2, 3, 4, 5, 6, 7. This one, yeah, this one is fake. This one is fake, and these two are fake, absolutely. This one that's highlighted is real. Yep, very good. All right, so when you do your projects, you will find a flag in here. After you get it working, you'll see the green box, and that shows you a flag. So you open this window, and there'll be something covered by green. That's what you use to turn in to get your points. So make a note of what it is. This is which flag it is. And you turn it in Canvas. And you'll find the instructions at the top here. So in Canvas, you find a flag. So capture an image showing the flag, and type the flag into the text field and turn in the image and the flag in Canvas. So my grader can check and make sure you actually found it. That's how you get points. Anyway, so once you learn how to use PeView, there's a flag defined by analyzing one of these files. And there's PEID. Let's take a look at that. If I run PEID on one of these things, now, last time I zoomed in another way. Let me see if I can manage to make a shortcut that will zoom in. This sometimes works and sometimes doesn't. But this is Microsoft's recommended way to solve this problem of things being too small. I can send to desktop, and once you have a shortcut, you can use Microsoft's compatibility features. And there are two compatibility features that might help. One is high DPI. Let's see if that works. That did not work. The other one is 640 by 480 mode, which would be nice if it would work, but it didn't work last time I tried it. Oh, it did work. All right, good. Well, it looks like VMware Tools are messing with it. I wonder if I can stop VMware Tools. I think I can. Let's go to Services. This might be why it worked sometimes and failed sometimes. Let's get rid of VMware Tools. I don't need them right now. Okay, now let's see what happens when I run this. There we go. Now we have something that's visible. Let's get that thing to go. There we are. All right. So now, yeah, I don't care about whatever you're telling me there. So if you open something in PEID, like one of those malware samples from the desktop, all right, it tells you what language it's written in. Written in Microsoft Visual C++ 6. It just looks for clues. And if you look at the sections, it's got .text, .r data, and .data, the usual stuff. So this is what a normal program looks like. But if you open a packed program, which I think is Labo 102 is packed, yep, then it cannot identify the language it's written in. It was not created with a normal compiler. And here, the first section is UPX1, and the sections are UPX0, UPX1, and UPX2. There's no .text or .data. So this is the result of the UPX packer, which makes files look strange and act in a different way. And that's, of course, something we'll play with. Let's take a look at Bintext. So look at the strings in a file. Here's glorious. Oh, I think I'm going to do the same thing. I'm going to try and make it bigger. Right-click, send to desktop. Okay. And let's see if high DPI scaling will work, or if we have to go to 640 by 480 to make it look good. Okay, that might make it big. We're going to see. Yeah, I don't care. Okay, that's pretty small. Let me try 640 by 480 and see if that looks better. Good. Yeah, that's going to be better. Okay. So, let's take a look at the strings in these files. Desktop. All right, so I go, and here are the strings. Remember, everything always has this program cannot be run in DOS mode. Here's the names of some segments. Here's some Windows API calls. Close handle, unmap, view of file. You can tell by the structure of the words. Also the fact that it ends in A. These are ASCII-based functions. Here's some libraries. Here's some low-level Microsoft API calls with the less friendly names. Here's one of those indicators of compromise, kearney132.dil, that we found by just looking at the raw hex. And here's C Windows System kearney132.dil, so that's a pretty good likely indicator of compromise. This malware is going to make that funny-looking file with a funny name, which is probably a clue that the machine is infected. Here's a warning, it pops up. Here's some more API calls. Here's more of that stuff. Yep, and that's it for this one. So anyway, you can tell a lot by looking at the strings, but of course you're not really proving that these strings are even used by the program. These patterns of bytes happen to appear. Usually they mean what they appear to mean, but you don't really know that. Anyway, that's the joy of Bintext, and there's a couple flags to find there. And then let's take a look at Dependency Walker. Let me do the same thing to try to make it big. There's, I think that's it, depends. File location. Yep. Send to desktop, create shortcut. Okay. And this one I think is not going to fit in 640 by 480. I hope this other setting will work. Let's try the system. Oh, that might be all right. Let's try a piece of malware again. My machine is awful slow. Just the CPU. Okay, there we go. All right. It had trouble analyzing it. All right. Anyway, here's Dependency Walker for what it's worth. It shows you the libraries, like here's kernel 32, and here's the libraries it uses. See, the strings showed us the same thing, but it didn't really prove it. Now we really know that it uses this close handle and copy file A, and so on. Here's ntdil and kernel base, and so on. And by the way, that flickering is some of my fake malware popping up boxes and being irritating. Like I say, once you run this malware on your machines, it does sort of begin to irritate you. So anyway, that's the joy of Dependency Walker. And I think that's it. Yep, you've got some flags to find here. So anyway, you should start doing your projects. Don't wait for them to be due. I'd start as soon as possible and, zip ahead to whatever you like. There's also a ton of extra credit. So you can totally make up for quizzes you do badly on or projects that you can't do by doing other projects. There's a ridiculous amount of extra credit. So feel free to do things beyond what's required. I picked what I thought was the most important stuff and put it in the schedule with a due date. You can turn an extra credit right up to the last day of class. All extra credit is due here in December, so feel free. Where do we locate the practice malware files? You will find them in whenever you need them. PMA 41, if you get this machine, they're already on the machine. But if you somehow don't have them, which happened to me, right? Somehow they were gone, then when you go to the project that needs them, you'll find a link here. You can download them from there. The only trick is you have to have no antivirus running, and as you see, your browser has to be kind of stupid too. Firefox won't let you download this stuff anymore, but Internet Explorer will. So, yeah, good. And we're only using a couple of those malwares. They're kind of old. I've been writing newer versions for some of these projects, but a few of them still use the old ones. We'll start writing our own code pretty soon. It turns out to be very easy to write some of your own stuff in Visual Studio. Good. Let me stop the recording.